All right, so the first thing we're going to talk about today is a property of functions called even and odd. Now, sometimes it has a little bit to do with numbers in the function being even and numbers in the function being odd, but that's not the only thing that we can go off of. But we're really going to focus on looking at our tables today. So if you have an even functions are symmetric about the y-axis. So what that means is they're mirror images across the y-axis. So the y-axis goes right through the middle of your function, and the left side looks just like the right side. Okay? X squared is a very simple example of an even function. Okay? The parabola x squared. The y-axis goes right through the middle of it. The left side looks just like the right side. But here's the key. Opposite x values have the same y values. Okay? Opposite x values have the same y values. So if I'm using x squared, for example, when I look at the table, x equals positive 3 and x equals negative 3 both have a y value of 9. That is an even function. So, and I'm going to write the function here. Let me use function notation. F of x equals x squared. That's our function. So x equals positive 3 and x equals negative 3. Both of them, y equals 9. So the easiest thing to do is if you're asked are functions even or odd, is to put it in y equals, go to your table, center it up here, where you've got negative 3 on one side, positive 3 on the other end, and you're looking to make sure that these values are mirror images of each other. Okay, 9, 4, 1, 0, 1, 4, 9. Okay, they're mirror images of each other. Okay, odd functions, they also have symmetry, but it's a little bit harder to see. We call those symmetric about the origin. So it's rotational symmetry. If we flip the graph over, it looks exactly the same as it did the other way. But the thing to focus on here is that opposite x values have opposite y values. So they're the same number, but they have opposite signs. So a good example of an odd function is the function x cubed. So let's use x equals positive 2 and x equals negative 2. When x equals positive 2, the y value is 8. When x equals negative 2, the y value is negative 8. So they have the same number, just opposite signs. And so when I look at the table of x cubed, let's look at that second graph. Look at the table. I'm already centered up at negative 3 to 3. Notice my y values. They have the same number, but they have opposite signs. Now, the ones on the left don't have to be negative. The ones on the right don't have to be positive as long as they are opposites when you pair them up. Okay? Now, in reality, a lot of functions are neither even nor odd. Okay? If I stick, let's say, x cubed is odd, but let me say that I put an x squared right after it. Okay? What if I put an x squared right after it? When I go to my table, notice my values, they're not the same. There's no symmetry there whatsoever. So that would be an example of a function that's neither even nor odd. Okay? So, and I've got a spot there for you to write in how to determine. Okay? What have I been doing? I plug it into y equals. Look at table. Negative 3 to 3. Look for same or opposite y values. Okay, so very, very simple concept. You just got to remember, even's the same, odd is opposite. Shouldn't be too bad. Odd, opposite, the O's go together. Okay, so let's do some examples to make sure that you know what I'm talking about. I've done 2 already. Let's look at a few more. We're going to try and figure out whether it's even, odd, or neither. Now, based on what I've shown you so far, looking at this first example, do you think it's going to be even or odd? Okay, I've heard both. I would say probably even because the power is an even number. Okay, negative 3x squared plus 4. Let's look at the table. We're looking at those y values. Okay, they are exactly the same. The y value for negative 3 is exactly the same as the y value for positive 3. The same thing for negative and positive 2. The same thing for negative and positive 1. So this is an even function. Okay, how about B? What do you think that one may be? Probably odd. Let's check it. All the powers are odd. Go to the table. Indeed it is. Okay, opposite x values have opposite y values. We've got negative 42, positive 42, negative 8, positive 8, positive 2, negative 2. So it is odd. Now, number 3, a long function here. It's got a combination of even and odd powers. So let's see what happens here. 2x cubed minus 3x squared minus 4x plus 4. That would be neither. Those y values don't match up at all. So it is neither even nor odd. Okay, let's look at D. 3 over parentheses x squared plus 2. Can anybody tell me what type of function that is? It has nothing to do with being even or odd, but what name do we give that type of function? And the variables in the denominator. We just did them recently. Rational. Okay, rational, it's a fraction ratio. Okay, let's look at the table. See our y values here, mirror images, so it is even. Let's look at the graph. We haven't looked at a graph yet. I want you to see this in the graph. See how the y-axis goes right through the middle of that function, the left side. We could fold it over on the right side and it would be the exact same thing. Okay, so you can look at the graph, you can look at the table. Looking at the function, we have an even power, a pretty good indicator. All right, E. What do we think about 3 times the absolute value of x plus 5? Even? Let's see. You got to know where that absolute value button is. 3, you go to math, over to num. It's the very first option there, ABS. Close the parentheses because the x is the only thing inside that absolute value. Plus 5 on the end. I'm going to look at the graph first. Okay. Looks symmetric about the y-axis. Let's look at the table. It is. Okay, this is even. Ooh, how about some trig? We haven't done any trig in this class, but we're getting ready to pretty soon. Sine of x. Okay, sine of x. Let's go to the table. Is it even or odd? Odd. Okay, it is odd. Opposite x values have opposite y values. Same number, just opposite signs. Now, they may not look exactly the same, but that's because they have to be rounded, and the negatives have the negative in front, so it loses a place there. But those are the same numbers. Now, do me a favor. Hopefully you and somebody beside you have this in your y equals. Okay, I want one of you to hold your calculator right side up, and I want one of you to turn it upside down. I mean, not like face down, but flip it around, okay? Hold them side by side. Look at those graphs. Do they look the same when one of them's right side up and one of them's upside down? They do, okay? That is the symmetry of an odd function. When you flip it upside down, it's exactly the same. Okay? So, pretty cool. The easiest way to see it is in the table, because during the test you can't say, hey, you graph this function too. You can't do that. So you have to be able to look at the table. But I did want you to see that property on the graph there. Okay? So I want you to practice with this. See if you can figure out even and odd. The next little spot there, a practice problem.